Let's take a look here at problem number 5. We're given a polynomial function of degree 4, and we're asked to find the zeros. So the first thing we look to see if there's any greatest common factor among all the terms, and there is. We can see that an x is common everywhere, and nope, that's it. All right, so let's factor out that x. And I'll have 6x cubed minus 13x squared minus 21x plus 18. All right, so we want to work with this polynomial of degree 3. There's no greatest common factor. We already factored out, I guess, if it did have another factor, we didn't factor out the greatest common factor. So let's look at the factors of the constant term. Factors of 18. 1, 2, 3, 6, 9, and 18. Factors of 6. 1, 2, 3, and 6. All right, so our list is going to be pretty long. Excuse me. So rather than list all of them, I'll just list it as we go. So let's try 1 and -1, synthetic division, and see if we can't find a 0. So we've got 3, 2, 1, and a constant term, so we don't have any missing powers. All right, so let's take a look at 18. And we don't get a 0 here. Did I say let's look at 18? Let's try -1. I think I saw this number 18, and I think I just randomly said 18. I hope I didn't. 6, -6, 19, -2. Nope, that's not. All right, so we would have 2 divided by 1, so let's try positive and -2 as a possible 0. And that's not going to work for us. Yeah, that's not going to be a 0 either. So 3 divided by 1, 3 is the next number in the list. as promised. Yeah, we found it. All right. And this is now a quadratic, so even better. I'm just going to shrink this up, give myself a little bit more room to work. So let's set this equation equal to 0. We got this factor of x. This 0, this 3 in factored form is written as x minus 3. And we have 6x squared plus 5x minus 6. So let's do our x see that the true power in this x method is when this leading coefficient is not equal to 1, and even when when it's a composite number with a lot of factors, this x method gives us a very organized way to attack this problem. All right, so what about 9x and negative 4x? That'll do the trick. So since the leading coefficient is different than 1, let's fill out a table. Let's use the first term and the last term along one diagonal. And the pieces in our x, we'll use that along the other diagonal. It doesn't matter where we put it along the diagonal. Both of those are even numbered. They both have a negative sign, so I factored out a negative 2. Both of the other ones are divisible by 3, so I factored out a common 3, and 3 times negative 2 is negative 6. Now, 3x divides both of these terms, and 2x divides both of those terms. All right, so we can come over and factor this completely now. We've got x times x minus 3 times 3x minus 2 and 2x plus 3. All right, so this original one had degree 4. We've got 4 factors here. It's going to produce 4 zeros for us, so we have found all of the zeros for this problem. These all have a multiplicity of 1, so they're going to intersect the x-axis by crossing over it at each one of these values. Here, the 2 steps, you can have the x here, add 2, and then divide by 3. Of course, I'm setting that factor equal to 0 and then solving it. That's what and then here, negative 3/2. All right, well, that's number 5. Hope that helps, and I'll talk to you later. Bye.